Let's talk about probability.
This is elementary statistics, practice test number 2. Module 2 covering chapters 4 and 5. Chapter 4 is probability. Chapter 5 is discrete probability distribution. And here's chapter 4, probability. So we're going to start with a couple of basic definitions. We want to define a simple event and a sample space.
A simple event is an outcome or an event that cannot be further broken down into simpler components. A sample space is the set of all possible outcomes or simple events of a probability experiment.
If two events are mutually exclusive, also known as disjoint, the probability that both will occur is 0. So let's go over the concept. Events A and B are disjoint or mutually exclusive if they cannot occur at the same time. That is, disjoint events do not overlap. We say probability of A and B, or probability of A intersection B equals 0. In other words, they don't have any intersection. In other words, A intersection B is an empty set. Now, this notation is phi, a Greek letter which represents an empty set. Therefore, the probability of A intersection B is 0. The probability of an event is always between 0 and 1. A couple of things I want to mention. Number one, a probability of an event A is defined as n of A over n of S. And this has a value between 0 and 1. Can it be 0? Yes. Can it be 1? Yes. It cannot be negative. It cannot be larger than 1. What about the sum of the probabilities of all final outcomes of an experiment? It must always add up to 1. So the sum of the probabilities of all outcomes in the sample space is always 1. One way to write it is the summation of P sub I equals 1. The only time it may not add up would be due to round-off error. If we don't use enough decimals, you may end up with like 0.99, or you may even end up like 1.0001, something extremely close to 1. That is still fine. It's just a round-off error that we came up with. To make some sense out of this, let's look at this experiment. When we roll a die on a normal basis, we have a die with 6 sides. So we get the following numbers, 1 through 6. When we want to write the sample space, we have to write all those numbers. 1, 2, 3, 4, 5, 6. A simple event is defined as any individual number. Pick a number, 1, 5, you name it. But a compound event is any event having more than one outcome. For example, we may be interested in odd numbers, which would be 1, 3, 5. So this is an experiment of rolling a die.
Answer the following. The number of combinations of n items selected n at a time is B. The number of permutations of n items selected 0 at a time is.
We do have a specific definition. So first, let's discuss the definition of permutation and combination here.
Permutation is an arrangement of objects in a specific order. Order matters. Example, the letter arrangement of ABC, ACB, BAC, BCA, CAB, and CBA are all counted separately as 6 different permutations. When n different items are available and r of them are selected without replacement, the number of different permutations, order counts, is NPR equals n exclamation point over n minus r exclamation point. Combination is a grouping of objects. Order does not matter.
So in short, when we look at the concept of permutation versus combination, both of them are dealing with n different items, and both of them we choose our items without replacement. But in the case of a permutation, order is important. In the case of a combination, order is not important. Because of that, ABC in the case of a combination is just 1. Whereas in this case, ABC, ACB, and the rest of them, that's actually 6 of them. Now, and the formula is, there are different ways of writing this, by the way. They may write it in this fashion, or they may write it as PNR, and it's n factorial over n minus r factorial. When we look at n numbers such as n, in general, n factorial, let's also discuss that. N factorial by definition is n times n minus 1 times n minus 2 times continue indefinitely until we hit 3 and 2 and 1. We just have an integer, a whole number, a natural number, but it has to be a positive one, and you count, you multiply by previous numbers all the way to 1. It's called n factorial, n factorial. Now, the number of combinations have the following formula, and we can write it as such, or you can write CNR. You can also write it as parentheses n comma r. They all refer to combination. So pay attention, the difference between a permutation and combination. You can even use a parenthesis with a couple of pairs. You can't do that for the permutation. This is a notation in case you come across it and you see different notations in different texts. Now, in the first case says we are choosing n out of n. In other words, n is n, so is r, so plug in. When we plug in, this is n factorial, this is n factorial, and this is 0 factorial. And 0 factorial is equal to 1, because the permutation of n item selected 0 becomes 1, or they even say by definition, therefore they cancel each other and they result in 1. As far as the permutation is concerned, we follow the formula, n factorial over n minus r factorial. We want to choose 0 out of n, therefore we keep the n unchanged and we change the r to 0 here. And this is another way of writing it, by the way. All of those items all the way to n minus r plus 1, by the way. So np0 is n factorial over n minus 0 factorial. I'm using this formula. I'm just replacing the r with 0. And obviously the denominator is n factorial. They cancel each other. We end up with 1. Here's the proof that the number of permutations of n items, when we select 0, the answer is 1.
A pizza parlor offers 10 different toppings. How many 4-topping pizzas, different toppings, are possible?
When we go with this type of question and different toppings, it becomes a simple case that order is not important, becomes a combination. The reason order is not important is because if your first pick is anything you like, let's say pepperoni, versus the second or third or fourth, makes no difference. You're going to get the 4 toppings. So it's a combination of 10, choose 4, order is not important. So it's combination. We are going to use this formula where n is 10 and r is 4. Now, of course, this is 10 minus 4 or 6 factorial. The answer is 210. Needless to say, you can use a calculator to come up with that. I have the command for you. in the modules, I will also look at one example where I show you the command. In the meantime, if you happen to simplify it just the way it is, it works out as follows. Notice the largest number in the denominator is 6 factorial, so you can write this as 10 times 9 times 8 times 7. You have to go all the way to 1, but since the denominator has 6 factorial, you can stop. Anytime you stop before 1, you have to write a factorial. They cancel each other. 4 factorial can be replaced with 4 times 3 times 2 times 1. And as you can see, the 1 at the end doesn't make any difference. If I multiply 4 by 2, I get 8. I can drop the 3 and replace this with 3. 10 times 3 times 7 is 210. In case nobody expects you to do this by hand, if you did that, this is how it works. In other words, it is possible to do it by hand.
How many 6-letter code words can be made from the 26 letters of the alphabet if no letter can be used more than once in the code word?
It's important to understand order is important. Simply put, because it's a code. And whenever it's a code, order becomes important. For example, if it's a password, if it's AB, it's different than BA. So with that being the case, it's a permutation when N is given as 26 and R is given as 6. And therefore, we have the following. Permutation of 26, choose 6. The bottom becomes 20 factorial. And I hope you realize you can write the top as 26 all the way to 21 and then times 20 factorial. Because of that, you can drop the 20 factorial in the denominator. Again, the reason why you can write this as 26, 25, 24, 23, 22, 21. And the reason you stop at 20 factorial because you can drop it. This is another way of writing it, and it becomes this number. Now, it's important that you show your work in this manner. This is the most important part as far as I'm concerned. The rest should be fairly elementary because you can use a calculator. But when you write permutation 26, choose 6, you're explaining as to how you are arriving at the answer.
A quiz consists of 3 true-false questions. How many possible answer keys are there? Write out the sample space and tree diagram.
I'm going to give you this formula. I want you to pay attention to this. N of S, the sample space, is the number of outcomes per stage. Raise it to the power of number of stages. So, what do I mean by that? A quiz consists of 3 true false. True false, that means there are how many outcomes? 2 outcomes per question. That's the number of outcomes per stage. And how many questions? However many. In this case, there are 3 of those. Therefore, this becomes 2 cubed, which is 8. So one more time, the number of outcomes per stage, true, false, that means 2 outcomes. Raise it to the power of number of stages. When you go with the tree diagram, keep it consistent. In other words, if the upper branch is T and the lower branch is F, then keep it up. You can change them, but if you don't, it's easier to follow. So look at the first stage. Here's your first stage. Here's your second stage. And here's your third stage. T, T, T. So look at the stages and we can separate them. So each question gives you 1 stage. So for example, if you look at this one is T, 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 whereas this one is T, T, F, continue. The last one would be F, 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 resulting in the following 8 pieces of sample space. Now we want a sample space for tossing 5 coins, and we want to see how many we get, and we want to write out the sample space. It's pretty similar to the previous one. Coins also have 2 outcomes heads and tails. So the number of outcomes per stage is the same as before, 2. How many coins? That would be the number of stages. 2 to the power of 5 equals 32 outcomes. There are 32 outcomes. To make sure everybody's following that, if you roll a die, there are 6 outcomes. If you roll it 2 times, it's 6 squared. 36 outcomes. If you do it 3 times, it's 6 cubed. So number of outcomes per stage, raise it to the power of number of stages. It's hard to do the 5. I want to show you for the 4, which is pretty straightforward. And now for the 5th one, you really need to add one more. So I've added one more here for you. So this is stage 1, 2, 3, 4. And I've added one more here. I got to do that for each and every one of them. I felt there wasn't enough space. I could do that for the last one, for example. And again, since the top one is H, we keep it as H and the bottom becomes T. So this is the 5th one, everybody. This is the 5th one. As an example, what do we have here? H, 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 H. There are 5 of them. What about the next one? H, 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 T. Continue the very last one. T, 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 H, T, 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 T. We can make up this set. So the sample space has 2 to the 5th, 32 samples.
A random sample of 100 people was asked if they were for or against the tax increase on rich people. Of 60 males, 45 were in favor, and of all females, 22 were in favor. Write the contingency table and answer the following questions. If one person is selected at random, find the probability that A, this person favors the tax increase on rich people.
You got to come up with the table and understand that when we say contingency table, we have a number of columns and number of rows. In this case, we have 2 columns and 2 rows because we have males and females, as well as those who are for and against it. And then we add a row and column for total. So you need to do that. And what I do here, male M, female F, for tax T, against it A, and let's enter those values. A random sample of 100. So that is the total. That's a grand total. That's a grand total. Whereas here, if you write it, it's the total for this column, total for this column, total with this row, so on and so forth. So this one is 100. Of 60 males, that means total of 60 here. We have total of 60. 45 were in favor. So that means we put the 45 here. So 45 here. And of all females, we don't have a total size. 22 were in favor. 22 were in favor. So I hope you see how we plug in those numbers. Take a look. A quick recap, 100, a sample of 100, that's the grand total. 60 males, so in front of males we have 60. 45 are in favor, so 45 under T, we chose the letter T to represent that. Of all females, because it doesn't give us any number, we don't have the all, but 22 of them, we have this one, were in favor. So with that being the case, we can easily finish the job. We can add these 2, we get 67. Then when we add these 2, we get 100. Now this one is 67, this one is missing. So 100 minus 67 gives you 33. These 2 must add up to 100. If this is 60, this must be 40. So if this is 40, subtract 22, you get 18 here. If this is 60, subtract 45, you get 15 here because of the total. So take a look at what happens when we fill up the rest of them and how we fill them up. This column, they should add up. they should add up. The rows, the same thing. And whether you go with the total here or here, they must add up to 100. These two numbers and these two numbers, they must add up to 100. That's the first thing I want to make sure we can come up with the table. The next thing is we want to answer the question. We are interested in finding the probability that this person favors the tax increase. Therefore, by definition of a probability of T is N of T over N of S. Let's make this a capital. This is a total size. By the way, when I do the probability, I like to start with the total sample size. I like to start with the denominator. In the case of a probability, the denominator is always the total sample size, unless it's a conditional probability. So N of S is 100, and how many of them are in favor? 45 and 20, 67. We've already come up with that, so we can just use that or just add them up. We did that when we filled up the table. The next is, what is the probability that this person is a female? You want the probability of F. Again, marginal probability, simple probability. The total size is a grand total. The denominator is 100. How many of them are females? You look at the total number of females, which happen to be 40. So 40 over 100, and you can rewrite this. If you want to go with the fraction, 2/5. If you want to go with the decimal, 0.4. If you want to go with the percentage, 40%. This person opposes the tax increase on rich people, given that the person is a female. Now, the moment you see given, your total sample space, the grand total, is no longer this. So I want to give you the formula, and then I want to give you the easy way out. So let's discuss the formula first. Probability of A given B is defined as probability of A intersection B over probability of B. Probability of B given A has the same probability in the numerator, which is the probability of A intersection B over the probability of A. So A given B versus B given A. Those are conditional probability. Generally speaking, this becomes N of A intersection B over N of B, because both of them are N divided by N of S. The same thing here. This becomes N of A intersection B over N of A. And that's really what I want to discuss as far as finding this easy. So if we go with this case, A given F, according to this, the person opposes the tax increase, so probability of A, given the person is a female. So after given F. So the way you would write it based on this, you would write probability of A intersection F over probability of F. Now, please understand this means N of A intersection F over N of S. This means N of F over N of S, and they cancel each other. We end up with this situation. Now, this is what I want to explain. You can intuitively see the answer. I'm going to go back to this. Anytime I'm doing probability, I'm going to start with the denominator. So anytime you see a conditional probability, immediately what comes after given? The person is a female. So my grand total of 100, which was a sample space, is no longer there. Now my sample space would be females. That means now the total of females is the denominator. So after given is the answer for the denominator. And this is exactly what it says here, 40. Now, A intersection with F, A intersection with F, 18. And of course, 18 over 40 is the same as 9 over 20, or 0.45. The simplification of that wouldn't be any problem. Now, I understand some students may have a little bit of a problem with the formulas. Needless to say, the formulas are provided to you. The next one, I want to show you how it can be easily done, even without thinking of the formula, as follows. This person is a male, given that he favors the tax increase. So as far as the probability is concerned, so the way we would write it, this person is a male and favors tax increase is T. Now, after the given, so I'm going to start with this. After the given favors the tax increase. Let's go see how many people total are interested in tax increase. 67, that's your denominator. I hope you see after the given is the denominator. So 67. So this is the tax increase column. Out of those 67, how many males? 45. To quickly recap, if you look at this one, after given, the person is a female, how many? 40. And this person opposes the tax. So look at this row and opposing tax, 18 over 40. Of course, we can simplify it. Whereas here, what comes after the given favors the tax increase, total of 67. What comes before that, that's the numerator, 45 out of 67. Now, of course, if I want to write the formulas, I can do that. Probability of M given T is probability of M intersection T over P of T, which is N of M intersection T over N of T. And the reason why is because it's 45 over 100, 65 over 100, or simply 45 over 67. Now, this is a precise answer. If you want to go with decimals, we want to put a bunch of decimals just to be on the safe side. Now, pay attention to the fact that when you read this question, this person is a female and favors the tax increase. This is an and statement, the intersection of events. In other words, you don't have a conditional probability. Your denominator is the total size, which is 100. But you look at the two events, females and favors, and you see that is 22. So 22 over 100, here's the formula, and 22 over 100 can be simplified to 11 over 50 or 22%. Formula says probability of F intersection T is N of F intersection T over N of S. So N of S is 100, and the intersection of the two has 22 members. Therefore, the answer is 22 over 100. Needless to say, everybody can simplify. This person opposes the tax increase on rich people or is a female. Again, the sample space remains as the total of 100. And the formula is this: probability of A or F, or probability of A union F, if you want to go with the set theory, is probability of A plus probability of F minus the probability of A intersection F. The reason we subtract that because the intersection is accounted for 2 times. Therefore, we have the following: N of A over N of S plus N of F over N of S minus N of A intersection F. In other words, look at this. The denominator is 100. How many A's? Total of 33. F's, we have total of 40. Now, how many are in common between the two groups? 18 has been accounted for 2 times. That's why we subtract. We end up with the following answer. And you can change it to any format you want, percentage unit. Are the events females and opposes the tax increase on rich people independent? Explain. The definition of independency is as follows. Events females and opposes the tax increase on rich people are dependent because occurrence of one of the events does affect the other event. Now, this is fine and dandy. The way they define independency, the occurrence of one has no effect on the occurrence of the other. However, the problem is it's vague and it's very hard to understand. So how do we do that? I like to do this mathematically. I'm going to prove that to you by looking at the mathematical definition. Probability of A intersection B is probability of B times probability of A given B. It is also equal to probability of A times probability of B given A. Take a look at these two formulas. If you do the cross product, you get to this. This is the general form. And what happens is that if the events are independent, probability of A intersection B becomes probability of A times the probability of B. In other words, probability of A given B becomes probability of A. Probability of B given A becomes probability of B if independent. Therefore, let's look at this and see why this is the case mathematically and numerically. We are looking at the events A and F. Probability of A given F, if we prove it's equal to probability of A, they are independent. Probability of A given F, remember F, how many? 40. Out of those, how many A's? 18. You don't even have to simplify. What about the probability of A? This is not a conditional probability. The bottom is 100. And how many A's? You want total of A's, which is 33. If these two numbers are identical, they are independent. Clearly, they are not. In fact, you can try the following. I leave it for you to do so. Try to prove that probability of F given A is that, and it's not equal to probability of F. As long as you prove one of them is good enough, we did prove this one. You can try this one on your own. I put a question mark at top. And the next one says, are they mutually exclusive? Explain. Mutually exclusiveness has a specific definition we've gone over. They are not mutually exclusive because a person can be both female and oppose the tax increase on rich people. But again, let's do it with math in the following manner. Probability of A intersection F is 18 over 100. If this number is 0, they are mutually exclusive. We just proved this is not, and therefore we proved with a number it won't happen. And that's important to do it in this manner.
Find the probability of getting the outcome of tails and 2 when a coin is tossed and the die is rolled.
This is the independent events we were talking about. Probability of A intersection B becomes probability of A times probability of B if they are independent. So when you toss a coin and roll a die, they are independent. So tails have as a probability of getting 1/2. This is 1/6, and therefore you multiply the two, you end up with 1 over 12. Why is that? The two events are independent.
A classic counting problem is to determine the number of different ways that the letters of personnel can be arranged. Find that number.
Permutations rule distinguishable permutations. When some items are identical to others, the number of different permutations, order counts, when n items are available and all n of them are selected without replacement, but some of the items are identical to others, is found as follows. N1 are alike, N2 are alike, and NK are alike.
So we use this formula, and the very first thing, notice this is 1, 2, 3, 4, 5, 6, 7, 8, 9. N items, we have 9 of them. Now P, we have 1. E, we have 1 and 2. And you write this for each and every one of them. So how many total number of letters is 9, and then we write each one how many we have. Now, following this formula, we get this. Notice, since they are all 1 factorials, with the exception of E and N, basically you have 9 factorial divided by 2 factorial and 2 factorial. By the way, 2 factorial is 2, 2 times 2 is 4. You plug it into a calculator, you end up with 90,720 different versions.
A box consists of 14 red and 36 blue markers. If we select 3 different markers randomly, what is the probability that they are all red with replacement?
Excellent. When we look at this with replacement, I hope you realize it makes it independent. We have 14 red and 36 blue. They add up to a total of 50. So probability of each red would be 14 out of 50. For the blue would be 36 out of 50. So 14 out of 50 can be simplified. Let's stick with that. Either way, it makes no difference. Since we want probability of 3 being red and we are doing it with replacement, the probability stays constant and it doesn't change from one stage to the next. Therefore, this is simply probability of 1 red to the 3rd power. So the way you would write it, as far as the formula is concerned, you want probability of R1, that means the first one is red, intersection R2, intersection R3, which is the product of each, simply because they are independent and each one is either 7/25 or 0.28, however you want to put that. So probability of 1 red to the 3rd, and we end up with 0.021952. So in short, with replacement, the probability doesn't change. Of course, 14/50, then simplify to the 3rd power. However, what happens when it's done without replacement? And that's what we want to discuss. I want to distinguish between the two. In that case, if we were to write the formulas, would be probability of R1. The first one has a probability of 14 out of 50. Then R2 given R1. And that now, instead of total of 50, we have 49. And the first one has been read. So instead of 14, we have 13. Times the probability of R3 given R1 intersection R2. This is R2. In that case, we go down to 48. The total is 50 and then 49 and 48. And the number of reds, 14, then goes down to 13, then goes down to 12. And you calculate that. I kept the top as 14/50 instead of simplifying on purpose because I wanted you to see that. And why it goes down. The total because you are not doing it with replacement. And of course, here's the answer. I want to look at a different method. Probability of all red is n of all red over n of total. Let's start with the total. We have 50, total of 50, 14 plus 36, 50. And we want to choose 3. So order is not important. Combination of 50, choose 3. That would be the total sample size. However, since we want them to be all red, then combination of 14, choose 3. If we were to do the tree diagram, and I want you to pay attention to see how that works, the red is 14 out of 50, the blue is 36 out of 50. I want to keep it as it's given instead of simplifying. You see why in a moment. So when you go to the next branch, again, we want to keep it consistent. All of them are red, the bottom ones are blue. So this is red, this is blue. So when we come here, this 14 goes down to 13. All of this, the second stage, we no longer have a denominator of 50. All of them have the same denominator, 49. But what about the numerator? Red goes from 14 to 13. But when you're in this branch, none of the blues have been chosen, so you have all of 36. In here, you have 36 blue, 1 is gone, and it becomes 35. Red is not gone yet, it's 14. Last stage, all of them have the denominator of 48. This one red is gone here, one red is gone here, only 12 is left, 12 over 48. Whereas in this branch, none of the blue is gone, so all 36 is left, 36 over 48. You can figure out the rest. If the probability of winning is 5 over 12, what would be the probability of losing? We are looking at what we call complementary events. So probability of complement of an A, they call it sometimes P of A naught, is 1 minus probability of A. Therefore, probability of winning is given as 5 over 12. Probability of losing would be 1 minus that. And I'm hoping nobody has any problem with fractions. 1 is 12 over 12 minus 5 over 12 is 7. Complementary events. And here's the definition of that. What are odds against winning? It has a specific definition. The actual odds against an event A, we use O and we use A naught, is the probability of its complement over the probability of itself. We express it in this format, A colon B or A to B, and they both must be integers. Let's write the odds against winning, which is the same as, in essence, odds for losing. Probability of losing over the probability of winning. This is 7 over 12. That was 5 over 12. This is a complex fraction. 12 cancels out the 12. You get 7 over 5. And you can leave it as that, or you can say 7 to 5 like this. If the payoff odd is listed as 6 to 1, 6 to 1, how much profit do you make if you bet $10 and you win? Payoff odds has a specific definition. And when it comes to net profit, payoff odds against an event A is net profit divided by the amount of bet. So take a look at this. So how much is the payoff odds? In this case, it's 6 to 1. How much is the amount of bet? 10. So what is net profit? Cross product. So we need to multiply this ratio. This happened to be 6. Let's say it was 6 to 4, then you would come up with 6 over 4 times this number. Whatever this ratio is times 10, that is your net profit. And I want to make sure everybody understands what that means. So if you bet $10, they do not touch your $10, they give you 60. A simple example would be a blackjack. When the payoff odds is 1, if you win, unless you get a blackjack, which is 1.5. So if you bet $10 and you win, your $10 is there, they add another $10. That's the concept. Unlike playing something like Lotto, where you lose the money that you put in.
When two different people are randomly selected from those in your class, find the indicated probability, assume birthdays occur on the same day of the week with equal frequencies. A, probability that two people are born on the same day of the week. B, probability that two people are both born on Monday.
Excellent. So we want to distinguish between the two. Please understand, on the same day, two people. So the first person can be born on any day. It doesn't matter. The second one must be born on that day. And that is interesting, the difference between the two. So no particular day is specified. The first person can be born on any day. Therefore, it is the second person that has a 1 out of 7 probability to be born on the same day. Their product would be 1 times 1 over 7 or 7 over 7. The first person can be born on any day, 7 out of 7. But the second person, in order for it to be born on the same day, has a 1 out of 7 chance. So basically 1 over 7. However, if we want them both to be born on a specific day, Monday, Tuesday, Wednesday, you name it. Now, each one of it has a 1 out of 7 chance to be born on that day. So the first person as well as the second person. So when we multiply them, we get 1 out of 49. Of course, understand we are assuming independence. So again, this one, same day, this one on a specific day. And that makes a huge difference. How many different auto license plates are possible if the plate has 2 letters followed by 4 numbers? So first we have 1, 2, 3, 4, 5, 6. So if we want 2 letters and 4 numbers, there is no restriction. So you put how many letters? 26 here, same here. Now, 4 numbers. Numbers can go from 0 to 9. And 0 to 9 means 10 digits. And that's why it's 26 squared times 10 to the power of 4. Needless to say, everybody can do the math. I just want to show you how we arrive at. Now we have 3 letters. They cannot repeat, and we can go with numbers that there is no restriction. So in that case, we still have 6 spots. So 3 letters. The first one is 26. Since we can't repeat it, it goes down to 25, and it goes down to 24. And then 3 numbers, no restrictions. 26 times 25 times 24 times 10 cubed. Now we have 4 letters and 2 numbers, 4 letters. Let's see how we can write that. This is 26. It says repetition is okay, so is this one. All the 4. And the 2 numbers, we can't repeat them. So the first one can be 10, but the next one must be 9. 26 to the power of 4 times 10 times 9. Counting numbers. For part D, now we have 4 places. We don't need this anymore. So here's the 4th spot. We have 26 letters. Each character is either a letter, 26, or a number, plus 10 gives us 36 characters, and there are 4 spots. There is no restriction, so 36 for each case, resulting in 36 to the power of 4. Again, I'm assuming everybody can easily calculate that, so we don't worry. In a first grade school class, there are 10 girls and 8 boys. In how many ways can the students finish first, second, and third in a foot race? Assume no ties. It's important to know first, second, and third refers to the fact that order is important. Therefore, we are dealing with the permutation. So how many do we have? How many are we choosing? We have a total of 18 students, 10 plus 8. And we want to choose first, second, and third. We want to choose 3. So permutation of 18, choose 3. This is the most important part. You can easily finish it, which is, of course, one way to write it is 18 times 17 times 16. If you want to use a TI calculator, you can start by putting the value of n, then press math, then select probability, go to factorial if you're interested in factorial. If you're interested in NPR or NCR, click one of those and then put the R. And in this case, 18, NPR 3 gives you this number, 4896. Or you can work it out. The girls finish first and second in a geography contest. So obviously, the moment we see first and second, order is important. So what is N? How many do we have? N is 10. And how many are we choosing? First and second, 2. So permutation of 10, choose 2, which is simply 10 times 9, which is 9. So we want to distinguish between order being important and not so. Now we want to select 3 boys for lunch duty. Definitely order is not important. So what is our N? Boys, N is 8. How many do we want? 3. It's a combination. Order is not important. It is a combination, and it's CNR or C83. If you go through the process, 8 factorial over 3 factorial times 5 factorial becomes 56. Or you can put it in, instead of NPR, put NCR. We want to choose 6 students for a team. No matter what type of a team, order is not important. Order is not, we just want to pick 6 students. So how many students do we have? 10 plus 8, 18. That's N. So combination of 18, choose 6. You can go through that process, or if you go with the calculator, 18 NCR 6, it gives you the answer. Again, I have all these questions next to each other because we want to distinguish between permutation and combination. Now we want 5 students be selected. How do we want to select them? Specifically, we want to pick 3 boys and 2 girls. Therefore, for 3 boys, N is 8, you're picking 3. For girls, N is 10, you're picking 2. And it doesn't say anything about the order. Order is not important. So each one is a combination. Multiply the 2. So this one times this one, the product of these 2. So you really have 2 spots. Order is not important. Combination of 8, choose 3. Combination of 10, choose 2. The product, use a calculator, come up with the answer. 4 girls be selected for a field trip. That's all. That means we didn't say anything about the order. Order is not important. It becomes a combination. So we go back and we see N is 10 for girls. So combination of N, choose R, combination of 10, choose 4. And again, you can use a calculator to come up with that. So this page is important. You can distinguish between permutation and combination.
In a lottery game, a player picks 5 numbers from 1 to 48. If 4 of the 5 numbers match those drawn, the player wins second prize. What is the probability of winning this prize?
Whenever I do the probability, I like to write formulas. And the formula is probability of winning is N of winning over N of S. And I always start with N of S. I want to know what is my sample size. If we understand the sample size, it makes it easier to calculate. So what is the sample size? Pick 5 numbers from 1 to 48. That means order is not important. Just pick any 5 numbers. So N of S is the combination of 48, choose 5. By the way, from 1 to 48, there are 48 numbers. If it were 0, it would be 49 numbers. So this is a simple combination of 48, pick 5. So that would be the total sample size. But N of winning, what do we need to do to win if 4 of the 5 numbers match those drawn? That means we want 4 to be correct. As long as 4 is correct, we are in good shape. And 1 could be incorrect. Again, order is not important. It makes the combination as far as the concept is concerned. Now, 4 correct out of how many? Out of 5. So combination of 5, choose 4. That would be the correct ones. But there's a possibility of getting 1 incorrect. So how many ways can you get 1 incorrect? Now, 48 minus 45. 43 of them are incorrect. Choose one. So take a look at what happens. First and foremost, this is a 48 minus 5. Okay. I want to make sure everybody understands where the numbers are coming from. So we want 4 correct out of 5. Combination of 5, choose 4. And 1 can be incorrect. If 5 numbers are correct, then 48 minus 5 would be incorrect, which makes it 43. We want to choose 1 from. So now we have this product divided by this combination. Of course, this is 5 and this is 43. The bottom, you need a calculator. You multiply the top, you multiply the bottom. Here's the answer. If they want it in decimal form, of course, you answer it with however many decimals.
A poker hand consisting of 5 cards is dealt from a standard deck of 52 cards. Find the probability that the hand contains exactly 2 face cards.
So again, I'm going to do the same thing. I'm going to write the probability as follows. The probability of 2 face cards, I'm going to call it 2F, n of 2 face cards over n of s. So this is what we need to calculate. Starting with the denominator, I'd like to know what is my sample space. I have total of 52 cards. And a hand has 5 cards, a poker hand. So that means I need to pick 5 from 52, and order is not important. Therefore, my sample space is enough. Pick 5 cards from 52, and order is not important, making it a combination of 52, pick 5. Combination of 52, pick 5. This is not important. You can even plug it into a calculator. So it's 52 factorial, n factorial over r factorial, which is 5 factorial, times n minus r, 52 minus 5 factorial. Now, let's look at what we want to get. Find the probability that the hand contains 2 face cards. So we want n of 2 face cards, but if it's total of 5, that means the other 3 are not. And again, it doesn't matter in what order we get it. So what is the numerator? N of 2 face or 2 faces would be n of 2 face cards and 3 non-face cards. Order is not important. How many face cards do we have? We have 3 face cards per suit. There are 4 of them. We have 12 face cards. And therefore, non-face cards are 40. I want to make sure everybody understands. This one is Jack, Queen, and King. Then we have 4 different suits. We get total of 12 face cards. And if we have 52 cards to begin with, 12 is gone, the rest of them are non-face. So if we want to pick 2 face cards, we have to pick them from the total number of 12. So, and order is not important. So for face cards, we are going to pick combination of 12, choose 2, and the rest from non-face card. That means combination of 40, choose the rest of them. The rest of 2, 5 minus 2, which is 3. So I want to make sure everybody understands how the numbers come about. So 12 is Jack, Queen, and King times 4, 12. And then 40 would be 52 minus 12. And number 3 would be 5 minus 2, because we have a total of 5 cards. So now we are ready to move on. So the top is combination of 12, choose 2, times combination of 40, choose 3. And the bottom, the sample space, is combination of 50, choose 5. Now, again, this becomes elementary. You put it into a calculator. When you calculate that, again, if they want it in the form of a decimal, so be it. If they want it in the form of a fraction, you have to simplify each one. And this is the simplified version of fraction in its lowest term.